CBC Docs. A thin vertical line separates the title, and alternating images such as bees, a butterfly, a human skull, computer circuitry. Then a man with gray hair and beard appears next to the title. A woman in her 30s runs along a roadway.
Zuri Scrivens is patient number 10 in a bold experiment to stop cancer.
You know, the whole thing for me has been a roller coaster. I had a baby, and there was so much joy. And then 10 months later, I had breast cancer, and everything changed.
At 33, Zuri had a mastectomy followed by standard breast cancer treatments. 9 months later, her cancer was back. It had spread to her liver and lymph nodes. Stage 4, incurable cancer.
You know, when someone tells you that it's spread, your head goes to the worst place possible. And I really thought that was it for me.
Then, Zuri was prescribed a medication commonly used for diabetes, and her cancer disappeared.
She walks with her husband and child.
That was over 3 years ago.
That's it.
Surreal. Not even real at all. It still shocks me, even though I've had 3 scans over the course of 2.5 years. I'm still a bit surprised.
She throws rocks on the beach with her child.
Zuri is a beacon of hope for cancer patients, a super responder in a revolutionary new approach to cracking cancer.
The title of the show appears, Cracking Cancer. Dr. David Suzuki stands outside a building.
For stage 4 cancer patients, hope can be very hard to find. But some people are finding it here in a highly experimental clinical trial at the BC Cancer Agency in Vancouver. As a geneticist, I'm particularly intrigued since the study unleashes the power of genomic research to fight cancer.
Inside,
Hi, Dr. Laskin, good to meet you. Dr. Janessa Laskin is the co-founder of POG, the Personalized Oncogenomics Clinical Trial. Personal oncogenomics, it's a very big term, but what exactly does it refer to?
Well, it refers to a program that we're running at the BC Cancer Agency where we're taking people's actual individual cancers and we're doing DNA and RNA analysis. We're trying to find what's driving that cancer and can we identify a drug that will block that cancer driver in each individual specific person.
DNA animation.
When the POG team analyzed Zuri Scrivens' cancer, they discovered something unusual.
Dr. Laskin.
She had this growth factor that was very, very, very high. And when we looked in the literature, that growth factor can be blocked by a diabetic medication.
Wow.
Zuri in the kitchen with her son.
Can you pick up your socks, please?
It sounds bizarre that Zuri was prescribed a diabetes drug for her cancer, along with a course of standard hormone therapy. But after just 4 months, no sign of cancer.
I feel very lucky. It's taken some getting used to. Everything's a little bit more beautiful.
More DNA animation appears.
Zuri's breathtaking recovery illustrates a radical new way of treating cancers, not according to where they originate in the body, but rather as a disease of genetic mutations.
I think what POG is going to show us is that there are abnormalities on a genomic level that run across all these cancer types. So it's possible at some point we might not say you have a lung cancer, we might say you have an EGFR, BRAF, RAS mediated malignancy,
Right.
But that won't roll off the tongue very easily. But in some senses, we're recategorizing cancers.
When POG launched in 2012, there were only 30 cancer patients in the trial. But initial results were so promising that 2 years later, they expanded to take in 300 people with incurable cancer. Trish Keating became patient number 130 and made medical history.
Trish arrives at a clinic with her husband.
What's your name? Oh, nice.
Trish had already endured 5 years of painful and exhausting treatments for colorectal cancer.
149.6.
Oh,
She was considered palliative when she entered the POG trial.
Dr. Howard Lim with a computer.
You see there's a spot up here on her neck that's glowing. That's consistent with her cancer. She was in pretty bad shape. Her PET scan really had lit up like a Christmas tree. Multiple lymph nodes were lighting up all throughout her body.
Staff work in a lab.
By sequencing or mapping Trish's entire genome, the POG team identified a specific protein that they believed was driving her cancer. And that protein could be blocked by a common medication for high blood pressure.
Dr. Lim.
I will fully admit that I was quite skeptical that it would work.
Despite his doubts, Dr. Howard Lim put Trish on the drug. The results were astonishing.
This next scan shows Trish's response to treatment after 4 weeks. I had to double check that this was actually Trish's PET scan because I couldn't believe that everything had disappeared.
He looks at her scan.
I actually went down to the radiologist to confirm everything because I just couldn't believe it. And I just called Trish to give her the good news.
You know, I am a miracle. I mean, I don't mean that like personally I'm a miracle. I just think that like the fact that I'm still alive is a miracle.
Trish's astounding remission is truly a wonder. She's one of a small group of super responders out of the almost 750 people enrolled in the POG trial by the end of 2016.
There are now 40 or 50 or 60 of these incredibly remarkable responses that have occurred.
Dr. Mark O'Mara is one of the world's leading genome scientists and co-founder of the POG trial.
He leads David into a computer room.
So this is the brain of the whole enterprise.
It's amazing. So, you know, they used to have supercomputers, but this is way beyond a supercomputer of the past. They say that the genome is the equivalent of 1,000 volumes of the complete works of Shakespeare. That's how much information is there. And you guys are now sequencing tumors and the healthy bodies and it's a staggering amount of computer power that you need.
It is. It's a game of significant numbers. But thanks to technology and the evolution of the technology, we now have machines that are capable of reading out all the DNA sequence, not only of tumor DNA, but of normal DNA, for a few $1,000s. And so this presents new opportunities.
Racks of computers.
To find the genetic mutation causing a patient's cancer, the POG trial compares their normal DNA, which is each cell's complete set of instructions, with their tumor's DNA. That enables personalized diagnosis and treatment.
Genetic data appears on video screens.
We're talking about the entire genome read out over a rapid enough time frame to have an impact on treatment planning. We know that in cancers, bits of the genome are broken. The concept really was, if we know what bits of the genome are broken, would we be able to take that into account on an individual basis, person by person, to help inform treatment decision-making?
A woman with blonde dreadlocks walks through a garden.
So we've got tomatoes,
Yes.
crazy tomatoes, and some artichokes growing in there. This is amaranth. Beets I juice a lot of. Kale I juice a lot of.
Patient number 542, Katya Mysik, is not a typical POG subject. She's put a lot of faith in alternative medicine since being diagnosed with breast cancer more than 6 years ago.
My protocol consists of a lot of medicinal mushrooms. I'm on CBD oil. I do all my juicing, do about 3.5 liters of juicing a day.
She juices in the kitchen.
When the cancer spread to her bones, Katya turned to POG, hoping the personalized oncogenomics clinical trial can find a treatment tailored to her. First, the POG team needs a fresh cancer sample.
So, how are things going?
So today, Katya's getting a biopsy.
Did you get any chemotherapy or
I've
whole
never
therapy?
had chemotherapy,
Okay.
and I've only had a tiny bit of hormone therapy.
Okay. And right now you're on
Nothing.
nothing. Okay.
She lies on a table.
Despite feeling squeamish, Katya takes a rare opportunity.
Dr. Hamilton, will I actually be able to see the tumor at some point?
Sorry, I thought you didn't want to see it.
Now I do.
Now you've changed your mind. and
I
you see it?
have. Welcome to my life. It's just always been abstract. I would kind of like to see what this is.
The doctor makes a small incision in her breast.
That was really intense for me, actually. It was so surreal to have somebody carving into my chest. So where's the tumor?
It's right in there.
I thought they were black.
No.
It was very cool to see my cancer, for one thing. I'd always thought it would be black, and it was white. Flip it over. Ew.
And it's just a bit of fat. The tumor sort of goes through this sort of the skin of the dermis there.
Well, it's all about facing everything, right? You spend your life with your head in the sand, and at some point you have to look at stuff. It was a big moment.
After closing the incision, a hospital staff helps her to sit up.
Don't get up yet.
Come on.
Katya stands and walks to the door.
Her tumor is sectioned to begin the analysis.
If you take half, I take half. Would that be?
You want half? Okay.
Is that okay?
Yep.
A woman works in a lab.
It will be many weeks before Katya gets her results. Sequencing may help her. It will certainly add to POG's growing body of knowledge about the genomic origins and treatment of cancer.
Dr. Stephen Yip.
The sequencing test that we do, we can actually identify the driver of these tumor cells.
The level of analysis through the POG computer is mind-boggling.
We can get about 1 trillion bases of sequence off of this thing.
A microscope slide.
And we read it out with those boxes. It's basically just a really nice microscope lens and a pretty fancy digital camera.
A very fancy digital camera. Researchers sequence a patient's whole genome, including roughly 20,000 genes. Then they search the mountain of data for the point or points where things went haywire.
Data scientist Martin Jones.
So what we're really looking for is to be able to hone in on the particularly relevant areas where we could try to target the disease.
Once they find a target mutation, the hunt for an effective tool to tackle the cancer goes lower tech, but no less fascinating. Teams comb through all available medical literature, looking for a drug already known to be effective against this particular mutation. The process takes about 3 months, an excruciating wait for people who've been diagnosed with incurable cancer. People like Marcy Johnson.
A woman wearing a winter coat and cap walks from a house to her car on the street.
Marcy Johnson was diagnosed with stage 4 lung cancer and has been riding a roller coaster of anxiety and hope for months.
Marcy drives her car.
POG genomic testing found a drug to target her cancer.
She arrives at the clinic.
Today, she'll find out if it's working.
Hi, good afternoon. How you doing? Good. All right, come on in. Are you here to see Dr. Laskin?
It's a huge and emotional leap joining POG. Less than 5% of patients in the trial have been super responders, and there are no guarantees.
Marcy.
Wouldn't it be great to be one of those miracle stories? There's something out there that is going to cure me, and if there is, Janessa's going to find it.
POG is new and cutting edge and very exciting, but it's still a very experimental clinical trial.
All right, so your last weigh-in was about 47.9 on the 2nd of December.
I signed the waivers, clinical trials, whatever she's got, make me a Janessa Laskin little guinea pig, because I'm here to fight the battle. 101?
101 pounds. Okay, so a couple pounds less than the last time. All right, okay.
For a month now, Marcy has been taking a chemo drug not normally used for her type of lung cancer and only available to her because she's in the trial.
Hey, Marcy. Nice to see you. Nice to see you.
In an exam room, Dr. Laskin joins Marcy.
Because the cancer metastasized to Marcy's scalp, Dr. Laskin is looking there to see if it's getting better.
Dr. Laskin examines Marcy's scalp.
That's a huge improvement. Yeah. Yeah. Yay. Yay.
Those pills are doing something.
Pills are doing something.
So that makes me hopeful that they're also doing something in the rest of my body, and especially that little shadow they keep telling me is on my lung.
And honestly, I don't think it gets any better than this, which is that we've done a test, we found a drug, the drug is helping you. That's pretty good.
I'm sending you an invitation to my 65th birthday party in 2020.
Okay.
By 2020, the personalized oncogenomics trial will have grown to include thousands of subjects looking for their own salvation, helping science to crack the cancer code.
Without POG, I would be sitting at home waiting, gee, should I not buy green bananas? To me, POG is my hope.
The nature of things. The nature of things. The sun rises slowly over the downtown Vancouver city skyline. Dr. David Suzuki approaches the BC Cancer Research Centre wearing a winter coat. Inside,
as a journalist, I can tell you that it's extremely rare to get access to the inner workings of a clinical trial. But we're invited to sit in on the weekly meeting of the POG team as they work together to crack cancer one case at a time.
In a lecture hall.
So really, I'm looking for guidance. Is there anything to suggest truly mTOR or MAP kinase pathways?
It may not always sound much like English, but the intense focus is unmistakable.
And as mentioned, this is a rare subtype of ovarian carcinoma. In each of these purple balls, you can see concentric circles, just like you would in a tree if you cut it down.
Normally, these scientists and doctors would be working in isolation.
So I think BTK should cover that possibility.
But here, oncologists talk with geneticists, while lung cancer experts confer with breast cancer specialists.
At the podium.
And of these, the ones of potential interest, we have NF1 homozygous loss of function mutation. It's lost one copy of the genome, and the remaining copy is mutated. So in terms
POG's interdisciplinary approach may be key to cracking cancer.
Dr. Laskin.
We have been a bit naive in thinking that cancer is one disease, that we could find a cure for cancer. And I think that cancer is hundreds or maybe thousands of diseases. And in each individual person, we are seeing very specific and individual coalescence of abnormalities.
That's why they all examine a patient's genomic analysis.
I would have thought if you have loss of both copies, it becomes a constitutively active pathway.
And debate possible interventions. At these weekly POG meetings, they initially worked with people's photos, but it was too upsetting for researchers not used to direct contact with patients. Now, they're back to using numbers. No big deal for patient 490. Carl Pollack just wants answers.
A man in his 60s with a mustache and glasses walks near a lake.
Let's get on with the job. I have some living to do. The cancer is cramping my style.
Carl photographs some birds.
2 years ago, Carl Pollack was diagnosed with colon cancer. It had reached stage 4.
Well, yeah, by the time they found it, my liver was completely covered with the crap, and it was starting to invade my lungs. If it were just the colon, they could probably go snip, snip, sew it up and be done with it. But let's not carve up Carl too quickly.
While he waits for his POG analysis, Carl's mind turns to the possible causes of his cancer.
I have a pretty good idea why I got the cancer, because all my life I've been eating lots of red meat and lots of processed meat, and it has the sodium nitrate and stuff like that, which in those quantities is apparently carcinogenic.
Carl stands near a radiation detector in a clinic.
Maybe Carl can take some comfort in how complicated we now know cancer to be.
So we'll have you up here.
Carl is helped into a CT scanner.
Well, when you think about cancer cells as being your own body cells just growing out of control, in some very rare cases, there's one or two triggers. Sometimes it's an inherited gene that's telling the cell wrong information, or sometimes it's a virus, and we know about virally triggered cancers. But I would say in the vast majority, it's a complicated relationship of environment and inherited genetics and some sort of mysterious combination of those factors. So when people ask what's caused my cancer, I think it's often 10 or 15 or even hundreds of things that we can't yet quantify for most cases.
You're doing great, Carl. You're just going to feel the bed move again.
While the causes are complex, one sobering fact is not in dispute. If you live in North America, your chances of developing cancer are estimated to be over 40%. And while promising, POG won't find a solution for everyone.
Carl sits in an examination room.
So they put me on a pill that was originally designed to lower blood pressure, which it did marvelously, but it did nothing for my cancer.
After 6 weeks, a scan showed that Carl's treatment wasn't working, so he went back on standard chemotherapy.
On one level, of course I'm disappointed, you know. I wanted them to wave their magic wand and make the cancer disappear. That didn't work. You know, that didn't happen. But at the same time, I'm realistic enough to realize that this is an experimental program and not everything they try is going to be successful. And I just happened to be one of the ones that were not successful. I still think that they're doing great work.
Oncologist Dr. Lim.
We think something's going to work. We hope it works. And sometimes we're lucky and it turns out that the theory is sound. Sometimes it just doesn't work out the way we think. And I think instead of a trial and error, I think that's just the process of learning.
Katja Mysick is driven in a van.
For Katja Mysick, coping with stage 4 breast cancer, the last few months have been an agonizing wait.
Waiting for the POG results is incredibly stressful. I had no fingernails left by the end of it. You think about it a lot. You go for long hikes trying not to think about it, but you think about it anyways.
Today, she will finally get the results of her genomic analysis.
It's a big opportunity and a lot's on the line, and you know it. So.
A doctor visits Katja and her bearded partner in an exam room.
Hi there.
Dr. Chia enters the room.
Pretty good. Okay. You? Okay. What's interesting is that you do have, within the tumor, there are 57 mutations. This is on the sort of middle-ish end.
But none of Katja's mutations can be targeted with an experimental drug.
I think it does support what we call hormonal therapy. I do think you should strongly consider being on some form of hormonal therapy. Okay?
Okay.
Questions?
Yeah, pretty straightforward.
Yeah, a little disappointing, but yeah.
Disappointed because?
Well, you know, you're hoping for a miracle. Everybody always is.
Yeah, I mean, the POG doesn't provide miracles. It provides you insights in what might be driving or not. It tells you that there's not a lot of driving mutations, which I think is a better associated outcome than having a lot of driving mutations.
The information does help Dr. Chia determine what kind of standard hormone therapy might work.
Great, thanks for your time.
Okay, all right. Okay, take care.
It's just not the cutting-edge answer Katja was hoping to hear.
Partner Steve kisses her.
Got some options, right?
Well, I was pretty crushed to realize that I didn't have any actionable mutations. I'd pinned a lot of hopes on it.
Keep on carrying on with your regime. You're doing great.
Katja wipes tears from her eyes. Elsewhere, cherry blossoms are in bloom outside a clinic in Vancouver.
Hi, Marcy Johnson, CT scan. Thank you.
Patients all know of POG's more spectacular successes, so it's easy to forget that about 25% of people sequenced don't get any experimental treatment suggestions, and those who do don't always have lasting success.
That's pretty good right there. Okay.
Marcy Johnson's been receiving treatment for several months for lung cancer, which has metastasized to her scalp.
She is helped out of the scanner bed.
The experimental drug she's been taking has had serious side effects. So now, Marcy's on a reduced dose. She's meeting with Dr. Janessa Laskin to see if the medication is still working.
Hey. Hello, Janessa.
Nice to see you.
Nice to see you.
I like your hat.
It actually has a purpose. It keeps that scab on the side of my head covered.
The only other thing that I have to tell you about the CT of the brain, and it's not a perfect scan, is that there were a couple of tiny little spots that are kind of in the, not in the brain itself, but kind of on the surface of the brain. So I can't quite tell what those are yet.
Marcy.
The CT scan is showing things that I wish weren't there. It could be going into my brain, which scares me. But I totally went brain fog.
Oh my God, it's okay.
Marcy is at home.
Marcy is struggling to be hopeful. The drug she's on has left her so debilitated, at times she can barely leave her apartment.
If I hadn't just woke up. I've gotten past the denial stage. You know, now I know I do have cancer, and it's stage 4. And I go back and forth. I still have my days where I'm just so positive, and then I have days where I'm not positive at all. And so far, it's been a year, right? So since my diagnosis. And that first oncologist I talked to gave me 6 months, so I'm already 6 months ahead.
Later, she sleeps on her couch.
Marcy will get 7 more months before she succumbs to her cancer.
David Suzuki.
Sadly, Marcy's story is still a more typical outcome for cancer patients who've reached stage 4. So far, personalized oncogenomics improves outcomes for less than 40% of patients who are sequenced. That's still a huge number, since everyone admitted to the study has incurable cancer.
Trish Keating practices yoga outside her home.
But cancer is a complicated beast, and there can even be nasty surprises for the super responders.
Keep your shoulders away from the ears as you...
Trish Keating was an early and dramatic POG success story. Her cancer disappeared for a year after she started taking a blood pressure medication. But then it grew back in a delicate spot near her spine.
I had surgery to remove that tumor. It was like an 8.5-hour surgery.
At a clinic, Trish enters a CT scan room.
Trish, hi.
Come on in.
You just put the water down there.
The POG team is trying to figure out why Trish's cancer came back. That may help them solve an essential mystery. Why does cancer change over time?
Dr. Mara.
I like to use infectious disease as an analogy, and we know how quickly the infectious disease agents mutate, they change, and they become... The flu vaccine is a good case in point. It changes every year, and why does it change every year? It changes every year because the composition of the agents changes. Cancer is a similar thing. So if cancers evolve, treatments will have to evolve to meet the cancer.
Now, 4 months after Trish's back surgery, a follow-up scan brings another scare, a suspicious shadow. So today, she's having a consultation with her oncologist, Dr. Howard Lim.
In an exam room,
This CAT scan that we did today, you're going to have a look at it, but in all probability...
It's probably your cancer back in the spine.
That's what I was thinking, I was worried about. Why did that drug that they gave me in POG kill the cancer that had metastasized to my lymph nodes? Why did it not get that one that was in my spinal column?
We redid the POG analysis, and it actually looks very similar to your original POG analysis. The only thing is it does show that the cancer is becoming resistant to the blood pressure medication, or at least the one in the spine is.
I'm so tired of living this cancer.
It's about...
I know you say, like... I feel like I'm on a roller coaster. And that's not even, like John said it better the other day. It's like every 3 months, just pretend that you're going in front of a jury who's going to decide if you get the death sentence or not.
Right. Fortunately, though, the remainder of your PET scan is still very quiet, so there's no cancer anywhere else. But the best way to look at it is they're more tested. Don't look at it as a death sentence. Look at it as getting more information so that we can help you live as long as possible, the best quality as possible.
It's a life sentence.
It's a life sentence, exactly.
Thanks, dear.
It's about maintaining your life.
Trish nods.
Thanks, Ellie.
Because the blood pressure medication is still blocking the majority of Trish's cancer, Dr. Lim decides to increase the dosage.
You've proven a lot of people wrong and all the stats wrong so far. continue to do that.
It's all the meditation I'm doing, Howie.
That's perfect.
person.
Yeah.
Thanks, dear.
Okay.
Dr. Lim.
The participants are really key for POG. They're the ones taking the courage to step forward and have their results analyzed.
Thanks. Bye, love.
Without the participants, there really wouldn't be a POG.
A young boy goes swimming.
Participant 417 joins the trial late in 2015. And so researchers begin studying a rare case that is not cancer. How far can POG go?
I'm just wondering, is it shrinking? Is it growing? Is it not doing anything? Or did it disappear all the way? It's like a mystery.
The boy has a swollen left leg. The nature of things. The nature of things.
Wow, what's weekend now? Hi, my name is Sagar, and welcome to my home. I'm going to an appointment at BC Children's Hospital. My leg problem is neurofibromatosis. I had it since I was born. I'm going to have a checkup.
12-year-old Sagar Dutt was born with a genetic disorder that causes tumors to form on nerve tissue. It's not cancer, but the tumor in his left leg really hurts.
Sagar climbs into the family car.
And POG may be able to help him.
Neurofibromatosis is one example where it almost behaves like a cancer, but not quite.
Hello, would you like to come through? We're ready for you.
So Sagar's tumor was sequenced, and the POG team has identified a medication that looks promising.
Dr. Rasek.
So what we really want to make sure is that we do it in the safest way possible, which is why we're starting at a very low dose.
But what if I still don't want to take the risk?
POG is not a treatment, it's a test. And so at the end of this test, you may or may not end up with treatments, but those treatments can be quite toxic. And it's critical that people understand that.
Sagar has already taken a skeptical eye to his proposed drug treatment.
Sagar tells the doctors.
I already looked at this, and it's a lot of serious side effects.
Sagar's nervous because he's suffered side effects before.
You don't have to make any decisions today. Today, we're just letting you know about everything, okay?
Yeah, I won't think.
Yeah, okay.
Sagar at an indoor pool.
Sagar and his family agree to try the medication.
I'm just wondering, is it shrinking? Is it growing? Is it not doing anything? Or did it disappear all the way? It's like a mystery.
He swims in the pool.
It's still unclear if the drug is working, but Sagar notices a difference.
I have a feeling that it's working. Before, when I used to go swimming, I couldn't do a flip. Now, since I was taking the blood pressure pills, I can do a whole flip.
Sagar does a flip underwater.
Sagar's is an unusual case that could open up a range of treatment options for other diseases.
David asks Janessa.
So really, POG is adding another instrument, another technology, like adding a microscope. And it's opening up whole new frontiers now. You're pioneers in this foreign area.
When you can bring minds, smart people together with different perspectives to tackle a problem, then you see inspiration and creativity on a whole new level.
Janessa rides her bike.
It was their desire to push beyond standard approaches to cancer that led Dr. Laskin and her colleagues to found POG. But when she met Jen Strack, Dr. Laskin wasn't anticipating that this case would result in a major breakthrough.
Hey, Jen. Hi, nice to
One that could potentially transform treatment for hundreds, even thousands of cancer patients. So tell us about your patient, Jen Strack.
Jen's case hits near and dear to me, of course, because she's my patient, but also because she illuminated a new area of cancer treatment that we are going to take and run with. Jen was a lifetime never smoker, completely healthy, so the diagnosis of lung cancer came as a huge surprise to her.
Dr. Laskin examines Jen.
Well, total shock. Like,
Jen Strack.
How did I get lung cancer?
Lung cancer is the leading cause of cancer death worldwide, and some studies suggest rates in non-smokers are rising.
Dr. Laskin completes the exam.
Yeah, so your lungs sound perfectly clear.
Okay.
Shortly after Jen Strack was diagnosed, her cancer metastasized to both lungs. Once her POG analysis was done, doctors noticed something strikingly different.
In the DNA of your cancer, so that's the set of instructions that are telling a cell how to behave, you've got two different genes, or these are sort of bits of information, and these two different genes usually don't live anywhere near each other on the chromosomes, but for whatever reason they've joined up and they're right next to each other and they're fused together, so we call that a fusion. But your fusion is quite unusual. I don't think there's much experience with seeing these two things stuck together.
For Jen, this fusion is an absolutely critical piece of her cancer puzzle. It produces very high levels of one particular protein, and that protein is driving her cancer.
Her case came at a really opportune time when enough published reports had come out that maybe this protein was a good target, but no one had yet been able to find a patient and actually test that hypothesis.
Jen, a brunette with a short bob, walks into her garden.
So she said, we think that this drug that's targeted to that mutation should work on you to stop the tumors from growing and spreading.
She remains on treatment now more than a year out, when really she was in quite a serious condition when we started.
I'm living proof that there's results that they're getting with their research. Oh, those look pretty good.
I don't think we've cured Jen. I think we have given Jen time with a tolerable treatment and a good quality of life. And if we can continue that on for her and for other people, that to me is a huge success.
Jen harvests some red flowers. David.
It's a huge success if you consider that Jen is the first POG patient with this particular mutation. Her successful treatment could buy more time for future cancer patients with the same gene fusion.
Janessa walks to her office.
How common is this new fusion that Jen has? Well, we don't know. Maybe we can go fishing and find it in even 1% of all cancer patients. That's a game changer.
POG patients are shown.
By its 5th anniversary in 2017, the POG team will have admitted more than 800 patients. They're aiming for 5,000. But Dr. Mark O'Mara is projecting far beyond that.
If you imagine a scenario, maybe 5 years from now, 10 years from now, what would you do with 100,000 fully characterized genomes, complete with outcome information, where you knew the complete molecular profiles and you knew how the cancers had behaved being treated with agents? I think you would actually have a resource that might actually revolutionize how we develop drugs.
The hope is that the more the POG team learns about cancer mutations, the easier it will be to develop new treatments. Patient number 10, Zuri Scrivens, embodies that hope. Without being too macabre, you've had how many years of good, high-quality life now?
5.
They take a walk.
I intend on another 45.
Zuri will stay on the life-saving diabetes drug, coupled with hormone therapy, as long as it keeps her breast cancer at bay. You were a lucky one. It worked, but it's not kind of a salvation for everyone. It's still very early in the technique.
Not yet, yeah. But, you know, the hope is the more patients you can bring into the program and test and compare, the better. So I think they're on the right track, that anything is possible. I've shown that anything is possible. My outcome has.
But with new Canadian cancer cases expected to increase by 40% over the next 15 years, can POG move fast enough to meet such enormous demand?
The nature of things. The nature of things. Jen Strack walks with her husband in a park.
Personalized oncogenomics bought Jen Strack a year of quality time.
What is the type of cancer that you're... Lung cancer? Yeah. Okay.
But the last few weeks have been difficult.
4 weeks ago, yesterday actually, I had brain surgery and they took out 2 tumors. One was the size of a golf ball.
Jen's cancer, which is driven by a unique gene fusion, responded well to POG treatment, but now it has spread. Today, she's undergoing immunotherapy, a cutting-edge treatment that boosts her body's immune system so it can attack cancer cells.
The future is all going to be about individualizing patients' care, understanding what's different about their cancers, and trying to target those runaway pathways. And understanding also how to blend in new treatments like immunotherapies into that milieu.
The immunotherapy is one of the things that did come up on the POG research that could possibly work, and we're giving it a shot. We'll see how that goes until they say, that's it, there's nothing they can do.
Jen Strack.
Jen's immunotherapy lasts for 6 weeks before her cancer grows more aggressive.
Jen receives a transfusion.
POG couldn't save her life, but it did give Jen Strack something priceless: more time. Dr. Laskin will continue to use Jen's earlier success to help others with similar mutations.
A large group of cyclists gather.
You are heroes among heroes in our battle to conquer cancer.
BC's Ride to Conquer Cancer. Everyone here has a personal connection to cancer. The fundraiser helped kickstart the personalized oncogenomics program.
My name is Zuri Scrivens, and in 2009, I embarked on my first ride to conquer cancer.
Who better to send the riders off than POG patient number 10?
Now, 3 years and another 3 scans later, no sign of active tumors. The research being done behind lab doors is so important. From me and my family to all of you, thank you so very much.
Today, Zuri Scrivens is POG's poster child. Young, active, and healthy.
Ready, set, ride!
Zuri watches riders cross the start line.
Money raised by the ride goes to the BC Cancer Foundation, which helps fund POG. And the money goes a lot further now than it did 5 years ago. The price for individual sequencing has dropped from about $250,000 to $20,000.
Dr. Lim rides with the group.
Only British Columbia residents can currently participate, but the benefits will flow far beyond BC.
Dr. Laskin.
I don't think that the future is everyone will get a POG analysis in the way that we do it now. That's not sustainable. But it might be true that in 5 years, the standard technology looks more like POG.
What do we got here?
Dr. Marco Mara consults with a colleague.
The business of studying the dynamics of cancer, the evolution over time, is something that we now are well positioned to do. We're learning incredibly important things about cancers that are very fundamental. And that information will produce a data set that will be absolutely central to new treatment strategies in the future.
Sunlight shimmers through tree leaves.
After a flare-up of her cancer, sensational super responder Trish Keating is back on top. The tumor on her spine shrank after her blood pressure medication was doubled.
I firmly believe that it's moving in the right direction. I want them there if I'm diagnosed again. Analyzing my next, it's not gonna happen, but anyway.
But does Dr. Laskin think the POG trial will ever find a cure for cancer?
I like to think of myself as an optimist. I think that's how you survive as a medical oncologist. What I hope to see in my career is making cancer a chronic disease with tolerable treatments. I think that's realistic.
Janessa rides her bike down a street as credits follow. The Nature of Things with David Suzuki. Cracking Cancer. Audio description by Finale Post. Directed by Judith Pike. Written by Judith Pike, Helen Slinger. Produced by Sue Rideout. Editor Alan Flett. Director of Photography Todd Craddock. Music composer Ben Mink. Production manager and post-production supervisor Allison Hill. Sound design Ewan Dean. Location sound Brent Culkin, Eric Davies. Online editor and colorist Lauren Wright. Produced with the participation of Canada Media Fund and Rogers Documentary Fund. Produced with the participation of Canadian Broadcasting Corporation.